All right, in number 47 here, we have the quantity radical 3 minus 4 times the quantity radical 7 plus 7. Well, here we have a binomial times a binomial, and don't let these radicals fool you into tripping you up about what to do. What do we normally do when we have a binomial times a binomial? Well, we FOIL, don't we? So first, outer, inner, last, right? So let's go ahead and do that. Let's go ahead and FOIL. So we have radical 3 times radical 7. We can multiply these two things together because, well, first, they're both radicals, but secondly, and probably most importantly, they both have the same index, right? They both have an index of 2. If these were both radicals, but with different indexes or different roots, we would have to first get a common root. We'd have to change the roots so that they matched. But here, we don't have to do anything. They both have an index of 2, and so we can multiply straight away. So we end up with radical, well, 3 times 7 is 21. And now we'll multiply radical 3 times 7, which is going to give us a plus 7 radical 3. And now we'll multiply negative 4 times radical 7, which will give us a negative 4 times radical 7. Remember, again, you cannot multiply a number by a radical, right? The only thing you can do to show that they're being multiplied is write them next to each other, just like this. And we talked a little bit more about that in the previous video, number 46. So if you didn't watch that, take a look at that. And we talked a little bit more about that. And then lastly, for the last, we'll go ahead and multiply negative 4 by 7, which gives us negative 28. And we can't combine anything here, so we're going to go ahead and call it a day right here. So our final answer, if I could draw a better box, how about just a circle, a big oval, is radical 21 plus 7 radical 3 minus 4 radical 7 minus 28. And there we have number 47.